Or if you are at your home, not sitting in this room, using your computer, I have a mechanism. I teach from a classroom or my home or from my office. You can see me live. Whatever I'm writing, you are able to get it on your system. We are able to do a video talk. We are able to broadcast session, like 10 users sitting at 10 different locations. I want to talk, they can talk. I can engage them. I can drop the polls, quizzes. I can measure the performance, like your interaction, like if you are interacting with me or not. I can give you small quizzes. I can get your response. I can get a feedback. I can set up a discussion wherein I have you people discuss among yourself for 5 minutes and give me some result. And communication again, like interaction aspects, whatever we talked, and file sharing, some kind of file sharing or assignment sharing of that aspect. So this is a very identified and selected basic aspects of e-education, which covers complete education system, offline, online, or be it anything. So on that matter, I'll going to talk sometime about a product which is designed by Adobe Systems. We call it Adobe Connect Pro, which was basically combination of a lot of small technologies that we have talked today, or you might have studied earlier. Combination of those technologies, designing into a product suite which can have the one use case which I gave you is one of the use case. So when I say use case, you can design the way you want to. If you want to set up your video calling software, you can use it. If you want to set up your e-education software, you can use it. If you want to have your FTP server in your college, you can use it. So these are the use cases. So I discussed one of the use case, and now I'll show you how this product actually works. So we call this product as Adobe Connect Pro, and it's a real-time collaborative application for web conferencing. So in web conferencing, it covers all the aspects what I talked with you about e-education. Concept of room, pods. I'll just give you a quick demo as well, and so that will give you a better understanding. Concept of room, pods, layouts, audio, video, screen sharing. So let's do one thing. Let me show you a quick demo. Let me see. Internet is working here. Internet. Anyways, I think it will take time, so let me just continue like this, and I'll give you, if we are able to set up the internet, I'll show you in the end how does it look like. Okay. So this is a common UI, user interface. So if you see this, the very first thing, like the most biggest thing is share my screen. If I want to show you something, like I'm talking about just think about e-education, think about you are not sitting in your college, you are in your home, sitting in your room or in your hostel, opening your computer, and we are doing this one by one, like all of you are sitting in different locations, and I want to set up a model wherein I can interact with every one of you. You guys can interact, talk, discuss concepts, share your ideas and everything. So this is a small model which I just try to focus. So when you see the biggest screen, which is called Share 7, and it talks about share my screen. So if I want to show you something, some presentation, I can either share my screen, my desktop in front of you, every one of you, you can see that, or I can share a presentation here in this bigger box, a presentation or a PPT for a PDF or a image file or a video file. I can share anything and you can view it. Second is, if you see on the left hand side, it says start my webcam. So if I want everyone to be in sync, like I want to see all of you guys separately, so I'll start the webcam for me and for all of you guys, so that every one of you can see me on their computer screen, not sitting together in a big room. Or you can also sit in a big room and set up a meeting instead of delivering it live, setting up our own infrastructure. I'll use the infrastructure of Adobe. And there's a chat pod, there's an attendee list. So there's an audio button on the top, which is for setting up a call. For example, someone of you are not able to sit in front of computer, but they're really interested in attending the lecture or the discussion part. So we'll set up the audio conference, and how it works. What it will do, it will call you on your number, on your mobile number, and you are walking somewhere, you are out in some other business, you can just set up your call, you can be a participant, you can hear everything, whatever we are talking about. If you have a mobile phone and you want to just see it as well together, because if you hear the audio, video and everything on your mobile phone, obviously it would have more bandwidth usage, and sometimes it may not work because of the less bandwidth availability. So you can set up a call here parallelly and open in your mobile phone, log into a URL which I probably showed you in an earlier slide, my.adobeconnect.com IIT Delhi, and then the meeting would start. We can do all the aspects, sharing it, a notepad is there, file share is there, video calling is there, audio calling is there, voice chat is there, and layouts are there, like what kind of layouts. There is an option for raise hand. If you have doubt, you just raise hand here, and the host, whoever is presenting. So like the categories are participant, host, and presenter. Host and presenters are almost same. So right now I am the host, you are the participants. Someone of you want to present some of their ideas or some presentation, they can be a presenter as well. So that was a very, looks very simple. Like if you see the GUI, if you try to give a hand to it, it would look very simple. Like you can use it for many purposes. So how actually this all happened? Like it looks so easy to understand, so easy to see, but if I go inside, so this is the architecture, what is working in the back end. So the whole structure is client-server based architecture. In this client-server based architecture, so the features which I talked about, for example, I say start my webcam. So when I'm starting my webcam, it has to be a live session. It has to stream everything to your system. We cannot cache it. If I'm sharing my screen, or there's an option for whiteboard as well on this screen, since this is image, I cannot show it now. But if I start a whiteboard, I try to write, it has to stream. So this, if you think, so this is streaming, so there must be a streaming server in the background. Now, consider the case where there is no streaming server. For example, someone is raising hand. So that is a single signal. We do not need to stream it. We just raise hand, that's it. So this is the meeting part, but if you look into the administration part, like this is the application which is launched. But in the application part, it has a management console. I have to add users. How can I add it? How I have created this meeting? Where is the console? How does it look like? So that is again a kind of HTML page which has some kind of forms, some entries. You make those entries, submit it, it will create a URL. Once you launch the URL, you'll come to this page. So if I talk about that aspect which I have not shown you, so obviously if you think, so there must be a web server or application server in the background which must be doing it. I talked about the audio profiles here, like on the top address bar, you see an audio button. So that is for communication. So when I say communication, so there must be some protocol being used inside. What could be that protocol? Obviously it would be using VoIP if I'm talking to some people, but what it is, so let's see. So this is the whole workflow, whole data flow for this Adobe Connect server box. Like if it has been developed and designed by engineers like you, so they must have planned something, they must have written all these codes, and this is what they have done, and this is what we just saw earlier. So what it has got, so in the Adobe Connect server box, if you see, so we have something called Web Services API, and then Web Application Server, and then Flash Media Server and the database. Now, starting from Flash Media Server, what Flash Media Server does is streaming. It takes care of all the streaming part. So when you launch the meeting, this meeting is mostly all the aspects are streaming, like share pod or sharing the files or anything. Whatever streaming is done by Flash Media Server. Normal client server architecture, request send response got is done by Web Application Server. And then on the client side, so this is what a client gets. This is what as a user you see it. So what it has got? It has got a browser on which you would obviously open it, and it should have Flash Player. Adobe, the legal owner of Flash Player, so they do everything on Flash Player. So you need to have a Flash Player, either on your phone or on your computer to have it. In between you see a lot of lines, so these look a little confusing, but they are not. What it does is the communication, how my server and clients are talking. They are talking with HTTP. I'll write, like I showed you this URL, http://my.adobeconnect. So HTTP is what? My communication media. HTTP is what they use it. When I say HTTPS, it is again secured environment with certificates, which talks on port 443 and it goes certificate authority blue box in between. And then RTMP It is for the streaming part. Where I'm using streaming, the whiteboard sharing, the video sharing, and all these aspects is done by streaming. So this is the RTMP. How it works, again, like I showed you earlier, RTMP is wrapped inside HTTP. In the HTTP URL, I'll specify, hey, hello RTMP, because you are not recognized by browser, so you will go with HTTP wrapped inside, and that whole packet will travel from server to all the clients. So this is a little more complicated structure for the same thing, whatever we have discussed, and I'll just try to give you a very quick overview how it works. So in the server part, like Flash Media, if you see in the center, so I have all the server part, Flash Media Server, Web Application Server, Web Services API. API is what, when I talk in major application development, what you have done in your assignments is like very small overview of these things. But when you do it professionally, so you do not make direct interaction with the code. You design APIs and you give APIs to use the user as they want it. Flash Media Server is for streaming. On the right hand side, below the database is Flash Media Gateway, which is a SIP server, which we have already talked and you have talked in the previous lectures. Streaming server is done by Flash Media Server, and on the client application, we have a web browser and the Flash player. And the client application is where you guys are sitting. Adobe Connect is the server part, and Flash Media Server, SIP server, database, they are the backend part. Now if I talk about video calling in this specific software, so this is more about giving you a case overview of how this application works. So if I talk about some video calling, how I'm doing the video call. So again, I'm setting up a SIP session using the RTP for video calling. RTMP is obviously used, but not for video calling. It's more for streaming the meeting room, the complete meeting room. But the video calling aspect is taken care by RTP, Real Transport Protocol. FMG server, if you see this diagram, so there's the biggest box is Flash Media Gateway. So this is the module which talks to the SIP server, some SIP server XYZ, and it basically interacts with SIP and tells, hey SIP, this is the audio, you have to broadcast it to PSTN lines and the VoIP lines, and they do it. This is a more complicated architecture, so it's again the same thing, nothing rocket science. In the extreme center, you will see a database and the connector server. Extreme center database and a connector server, which is connected to Flash Media Server via conference bridge, PSTN gateway and SIP, and then Flash Media Gateway. The PSTN gateway is to call someone outside India, like any landline phone, and then which is done by DTMF and SIP. DTMF is dial tone, multiple function dial tone dialings. So sometimes you call to some customer care and they tell you, if you want to talk in English, press 1. If you want to talk in Hindi, press 2. So that is DTMF, which is again, and that customer care center is again example of SIP. Your all calls is handled by a system, not by a person. And they have configured a SIP. You can never get a call from those numbers because SIP does not have a capacity of calling you. It just set up the communication. So that is a DTMF. Flash Media Gateway is connected to Flash Media Server, and then the meeting client in green, which what I have shown you on the image in the slide. So this is a service component. I'm not going to give much stress on this. It's just how it has a database, a reporting database, shared storage, Flash Media Server, RTMP traffic, how it is handled on which ports. So mostly, just for your knowledge, all the secure communications, HTTPS, happens on 443. Normal HTTP request goes on port 80. The basic components, the connector server and the Flash Media Server. So connector server was written in Java, core Java, completely core Java, and Flash Media Server, which is doing the streaming, is completely written in C++. So see, this is the C which have been studying how are the extension and the levels we are using it. So this Flash Media Server does all the encryption and streaming part. Connector server is doing all the client server requests, the UI part. Normal web application server architecture is what connector server, and the streaming architecture is what Flash Media Server. Meeting server app, the image which I showed you for the meeting server is again written in ActionScript, Flash, kind of designing, you can use anything. And Connect Center, the administration part is again a simple web page designed in HTML and Flex. This is the same Meeting client application, I've already told you how it is being used, streaming and all those HTTP, HTTPS requests, so I'll just skip that. Application database, shared database, workflow, okay, architecture features. So in this architecture, this is one of the major enterprise products for Adobe systems, and the architecture is really important, and I would not cover all those in details. I will just cover one of them. So the major part is access control, reporting, user management, scalability, delivery, integration, extensibility, compliance, and security. So these all things are something that is very common. I mean, if you just brainstorm or just read all these things, you will get to know what exactly is happening in these aspects. So if you just go through quickly the subtitles, so they are very simple. If I say access control, authentication, everyone knows about it. Reporting, I just need to have measure the interaction, the reports you pass or you fails in your online exams, so that thing. User management, you need to be a part of my system, I have to manage you. Scalability, which is an important aspect, and we'll talk again later. Delivery, how I'm delivering it, tunneling it, streaming it, live streaming it, offline streaming it. Integration, how it is integrated, single sign-on or with LDAP. For example, I do not have to give everyone a new user ID and you have a new headache to remember everything. Just use your email ID, that's it. Your Gmail ID, or if you have your college email ID, just use that. That's a single sign-on or integrating with your single sign-on. Security, SSL, the certificate, the HTTPS part, that is how we are securing it. Compliance, setting up some rules that I would not, whatever rule could be, like, it could be anything. For example, I set up a rule that I can only have the users who are in class 6 or first year or second year or like that. So these rules can be done. Extensibility, how I can extend it with other things. For example, I gave you product, you see that this is something you don't want, you want to change it. So you will ask me, hey, can you give me your software delivery kit or SDK, wherein you would code it as per your need. So most of the things, like if you go to Google APIs or any other big companies, any products, if you want really get into the development part, you can easily get the APIs or SDKs. Like Java releases SDK on which you just write the program. Similarly, some companies release the APIs for their product. You learn that API, you can design anything as per your use. Some companies giving some product like this bottle is like this way, and this company has released their API, you make a rectangular bottle with their APIs and you are free to do it. You have got the license when the API is public. Now scalability is important thing. How I can scale it? So in any software you make, what happens, I consider a case, I design a simple application wherein a simple chat server application. And what I see that I told all my friends, hey, test it, use it and tell me if there's any bug. 100 people joined, it worked fine. 1,000 people joined, it worked fine. Now someday I observed that 10,000 people joined and suddenly everything goes off. Suddenly everything is crashed. Now what to do? So I have to think about the scalability part. With the more usage, how I'm going to manage the scalability thing. So there are many reasons to brainstorm. Think why it has crashed, either because of the software failure, either because of not having the capacity to handle this much bandwidth of traffic. So all these aspects you have to think, and then we talk about scalability. I'll just talk about clustering, which is a very interesting topic. So clustering simply means, like instead of reading the definition, I'll show you what exactly it is. Let's talk in the context of how Google does it, for example. So this is one server for Google, and this is you. You just enter on the Gmail, open gmail.com, enter your email ID, it will go to this box, and again a page is prompted on your system. So think, this box must be having some limitation. How they are doing it? Like it can handle 100, 1,000, lakh, 10 lakh, crore, 10 crore, but there must be some limitation. And the usage on internet is increasing exponentially every day. So Google has to think, or you being the head of the Google, you have to think how you have to manage this aspect. So what you will do, instead of request going to this is server 1, this is server 2, you will set up a server 2 as well. Now, either you will tell the user to go to server 1 or go to server 2. So if you have this kind of model, then this server 1 has a database, so this server 2 also has to connect to the same database. Then again there's a problem will occur, like for example the server 1 has a limit of 100 people, for example 100 people. When 100 people will log on, it will go to server 2. So in this case there is a situation when the load sharing is not proper. So what I can do, if I can decide when the request is coming, if I can design a mechanism, I can think, hey, which one has got more load, I'll send the traffic on that server. So that would be easiest job for both the servers. So what I'll do, instead of going this request directly, I will use a load balancer here. So what is load balancer and what it does? So what happens now, this request will go to load balancer, and then load balancer will know load balancer is connected to all the servers. So if you know all the cloud systems and everything, they have got a load balancer, and then load balancer knows all the servers, their state, how many users are on it, how many traffic is on it, and then it tells the user, or it actually, you don't know which server you are going to. Load balancer decides and push you to server 1 or server 2 or server 3 or server n, whatever it is. So that is decided by load balancer. Now what is load balancer? Load balancer is nothing. It could be a hardware device, it could be a software device, software application. So for example, Microsoft NLV Network Load Balancer is a software. You can download it from internet. You can set up your web server application, use it. If it is a hardware device, buy it. F5, Cisco, these companies make the load balancer. What load balancer does? If you just think about it, what it does, it knows the number of server, how many server it has. Server has a connection with the load balancer, and server keeps on sending load balancer, hey load balancer, I have got 5 people on me. Second tells the load balancer, hey load balancer, I have got 10 people on me. Now load balancer will check, 5 is obviously less than 10. Next user comes, it will force it to the server 1. So this is a very simple logic on which this load balancer is based. So the Adobe Connect Pro application, so this is the actual architecture of the whole system, and this is very complex for you to understand as of now, but I'll just talk about the scalability part. So on all the top 4 screens on the extreme first layer, so these are the clients, either a user logging in through a desktop machine or a laptop or a mobile device or anything. Then there's a firewall, then there's a connect center, and the big gray box is load balancer. So all the requests will go to load balancer. And this mechanism is not for Adobe, for any big company or any big server or any email server or any Facebook server, for example. They have a load balancer. Your request is not going to their server directly. It's going to a load balancer. In fact, the more complicated architecture would look like something like this, like LB1, LB2, LB3. There are 3 load balancers. They can talk to each other. This has got n number of servers. This has got n number of servers. This has got n number of servers. And there is a load balancer on the top which is connected to these, and this is the user. When it sends a request, it will go to this load balancer. This load balancer will decide which load balancers to go, and this load balancer will again push up on that server. So there was a last year Google server on India was down, and when you open google.com, it will put you to google.jp. They have redirected all the traffic from Asia, South Asia to the Japan server. So that was an example where how this scalability things matter. So clustering, we already decided. Now in this aspect, so for example, just I would like you to stress again, now when I'm doing client server architecture, I need to have a database. So this is my database. So now if this is my structure, so when user is trying to hit this load balancer and this server, so it has to connect to the database. So how it works? So this database would be connected to all these servers. This is one model. You think many other models, and again you can implement it. I can have this database connected to another database which is connected to this load balancer, this is to this load balancer. Like this you can design, take white paper, design those architecture and see if that is feasible or not. And this is how we do all the clustering aspects. So this is what I have just shown you. Maybe switch to slides. Okay, so this is what I have shown you, and You see a simple client, there's a load balancer and there are 3 servers, and this load balancer will tell you, hey, take me to server 1 or 2 or 3. This is again what we have discussed about load balancer structures. Second thing, scalability, how I can talk about another aspect. So if you think, let me just draw it here. This is also a good concept. I call it edge server. So what is that? So this is your server, and this has a capacity of 1000 users. If you want 2000 users to connect it, what you have to do? Either go for a clustering, which is an option, or let's discuss about a new opportunity that you can do, that this server supports 1000 connections, right? 1000 users or 1000 connections. So let's talk in terms of connections, making it in a way how it works. So obviously what I can do, with one connection, I can use another server which again has 1000 connections. So now this server has got only 999. 999 connections can be done to this server, and one connection out of this 1000 has been used to set up another server, and this server can now connect to another 1000 connections. This is not clustering. I'm not load balancing it. I'm just scaling my network, and this concept is called edge server. And this is one of the innovative concepts which is being used in Adobe's architecture. So if you see the slide, so I have an origin server. So this whole structure is, we call this new box which I have created as edge. The old box will be origin. Now how does this whole architecture works? I have simply extended, I added a new box, I made the limit to 2 times, like it was 1000, now it's 2000. And out of this 2000, 1999 connections are the users, and one connection would be the connection with another box. So this is another aspects of scalability. Okay, so let's do a quick exercise, and I'll give you a situation, and then we'll what we have learned, we'll see how we can use it, either use in terms of this application or just brainstorm if we can think of something or not. So what situation I have, consider a place, let's say Arunachal Pradesh in India. Good part is there is no network, it's mountain everywhere. We have electricity but no internet. We have phone connections but not very good connectivity, no bandwidth. So for you, consider a situation wherein this is a village, and in this village there are, like for example 10 houses, and I have to set up a communication model. I do not have any LAN, no LAN wire, no internet. Whatever we have learned, is there a way we can do some kind of communication model? When I say communication model, should be like that all those 10 families can talk to each other. It's raining everywhere, they cannot go every time if they have to go. There is no phone system, nothing, but they want to be in connection every time. So once we just think about it, then I'll tell you how we can extend it in e-education domain or telehealth consulting domain or anything for that matter. You guys can explore more on this model. So just take your time and give me any suggestions. What would you do related to this class, or any out of box thinking is welcome. So this is a problem. If I have to this house number 1, 2, 3, 4, you have got some money, you can obviously, if you need any resource, tell me what resource you would think of, and how would you can set up a communication that 1 is able to talk to 2, 2 is able to 3, and 4 is 1, and like that. Just take a minute and tell me if you can think of something related to this class, any out of box thinking, anything. Any rough idea, anything, help me with any blank idea, anything. If you are thinking of anything, any approach, any idea coming to your mind, any raw idea. Just say any blank idea, like at least I know that you are thinking. So let's then talk what I have in my mind. How would I do it if I have this kind of situation? I'll simply buy a box, set up a SIP server, that's it. I mean, after that what to do? Just set up a SIP server, set up a wireless router or wireless network device, and then have these users connecting to you, and that's it. And you can set up your video call, audio call, any communication system. You don't need really an internet. So why I talked this case as a quick exercise for the telehealth consultation possible architecture, because consider a situation in rural parts where we do not have internet, or if we do, the bandwidth is very poor. You can simply send a request. Even that's not a fairly big request, fairly big URL, just a single binary request can be sent. So we cannot think of anything that I can or we can use for teleconsultation or e-education or any of those aspects for that matter. So the SIP has a capacity that it does not need internet. It simply needs a intranet connection, or it needs a connection with a user. So I can either use a switch, network switch, connect it to the SIP. I'll use a switch, connect one port to the SIP, and connect these ports to these computers. That's it. So they are connected. They are in a network. Cost for buying this computer and installing the SIP server, and cost for this LAN wire, and cost for this switch device. That's it. And those users, if they have a phone, it's okay. If not, they have a phone, we can use a simple device, cheap tablets, or computer with limited capacity. So obviously infrastructure cost would be there, but with this minimal infrastructure cost, you are able to make those 4 people talk to each other, share their videos, share communication channel, everything. Now when I say telehealth center, so telehealth center could be something like that. Problem is I do not have network everywhere, but I want to set up a communication media in a way that there should be no people getting not proper medical attention. So what can I do? So there's one again possible model which we can think of. So this is one village, this is another village, this is third village. So this is SIP 1, SIP 2, SIP 3, and there are these dots are users, these dots are users, these dots are users. So these dots are connected to SIP 1. So now someone like this dot, let's say this is A, wants to talk to X. So how would he communicate to X? Obviously it cannot, because these are not connected. But if we can think of a model wherein we can connect them, obviously we can do that. Again, design a switch, make them LAN connection, or if that is not feasible, use a Wi-Fi device, any device which works wirelessly, and connect them. You can always make them talk to each other. Or at a higher level, you can assume that these villages does not have an internet, but there is a communication mechanism in these villages. So this A will basically call to this SIP. This SIP will check their registrar, like if that address X is this here or not, then it will go to the device, any intelligent device it could be, or the SIP knows that SIP 2 and SIP 3 is also there. It's talking to them because it is connected some way with them. So it will pass on to SIP 2, or if it is directly to SIP 3, it can pass on to here, and then once it is done, then the connection would be established. I can use it in telehealthcare center, wherein I set up a small center where I have a person, a nurse or a intelligent person or a trained person who can collect the information from the villages, send the information across to the hospitals, all the precise information, all the case information, images, video and everything, and doctors can review it and try to give any immediate medical attention if that is something can be done online. If something it requires person to visit to hospital, obviously they can do some primary medication, and then meanwhile they can move to the hospital. So these things are really useful, and you can think of about them a lot. Like just brainstorm any problem, take any problem, think about it, how you can use all these aspects. Because in media processing you have already learned the compression, how you can compress the video. When I compress it, it makes easier for me to transmit it. So obviously when I take all those communication channel, I'm sending all this communication channel by compressing it, by intelligently compressing it, not just simply doing zipping or something. So that is one of the case. Again, this SIP or streaming is something you can again use. You can design your own chat servers using streaming, and using SIP you can make it work on any network, your local network, your internal network, create a network with all those things. Any questions for me? Anyways, any questions? I'm not able to, I wanted to give you a demo of how it works, some of those features, and the main idea is to let you know what you have studied, how you can practically implement it, or how you can think about implementing it. So I just gave you one case scenario. So like this, Adobe Connect is a product from Adobe. Microsoft has their product called Link. Cisco has again their product. Salesforce has again their product, which is working on these aspects what you are studying. Nothing more than that. And it just those things already available, you just need to think about it, design something, write it in a proper manner, or code it in a sense, and deliver it. And that's a product, and that's how whole world is running it. This product which I showed you, the Adobe Connect, if I talk about details, so most of the universities of United States, some of the universities of India, they are using it. Many corporate companies, they are using it for their healthcare systems, their e-education system, their training system, hosting online webinars, online seminars, everything, because this software does not require any hardware. So right now the teleconference system which we are using, it's more of hardware dependent. Everything is done by costly hardware. But if talk about this software, it's not you need very high-end hardwares. But again, it has again the problems. It needs bandwidth. If you have poor bandwidth, you cannot use it. So there are many pros and cons. So the main idea for this thing is make you guys think, realize whatever you are studying, how important is it, raise out your questions, whatever you read, try to find out where you can apply it. Just not a class attending and reading it and you are done with the exams. No, think about the application, because this is kind of very practical subject, and it's a very good subject where you can learn a lot of things. So any questions for me on this part? No questions? Yes, no, maybe, can't say anything. You have to be a little louder, please. Was it that boring? Anyways, so it's good you attended this, and this is my email ID. If you need anything about this subject, I can help you in any way, or if you need any guidance, because just think of something, whatever you are learning, at the end you should have some kind of motive that show your learning. Design some applications, or think of some application, think of some innovative idea, participate in all those innovative idea competition, challenges everywhere, and try to implement this knowledge, just not attending the class and using it. Reuse it, think about it, brainstorm it, and innovate the things. So if there's anything ever, just you have my email ID, send me an email. This lecture material would be available online on the course website that you might be having. So thank you and all the best.